Hey everyone, welcome back. So in the last episode we got the Vulkan wrapper class built, the v-deleter that we used from Alexander's tutorial. And in this episode we're finally going to get into some Vulkan code. So we're going to create our Vulkan instance, and then we're also going to incorporate the validation layers. Vulkan doesn't have validation layers built in, but what those do is they give you some feedback when there are errors. And since Vulkan doesn't have any way of giving feedback, these are actually part of the Vulkan SDK that we downloaded, and we're going to incorporate those so that we can find out when we actually encounter something wrong. So let's start with the instance creation. So to create a Vulkan instance, first off, we need somewhere to store it, and we already have that. We have the v-deleter right here. The instance that's wrapped in the v-deleter, but nothing's been assigned to it. So we already created a create instance function, and it's empty. So the function that we want to call to create the instance is real simple. It's vk create instance, and you'll notice that this one has 3 arguments to it. The first one is a reference to a create info struct. We're going to mess with that in a second. There's going to be a lot of definition for that. Then you also need to set the allocation callback, which is that p allocator right there. We're going to just set that to null pointer. There we go. Now, that has to do with managing the host memory. Managing the host memory for the Vulkan system. But setting it to null pointer means that Vulkan will use its own internal allocator, and that's going to be good enough for us at the moment. It's a lot simpler than trying to figure all that out. The third parameter is going to be the actual instance handle that we created before. So this is how it's going to assign it to the instance that we have over in planetvulkan.h. So we're just going to go ahead and do instance, and normally you would pass in a reference to it, but in this case it's going to be replace, since we're using that wrapper class. So that will just replace what we already have with the new thing that was created. And to make sure that we handle any errors, instead of just declaring it this way, let's go ahead and put it inside an if statement. And we're going to check whether this returns vk success. Any of the Vulkan calls will return vk success if they work out. And if they don't, then, well, we will find out. So now if it's not vk success, we're going to go ahead and throw an error. Go ahead and runtime error, just like before. And failed to create instance. That way we know if something went wrong. Otherwise, this isn't necessary at all, but I would just like to have some sort of notification that things went well. We're going to go ahead and see out, and Vulkan instance created successfully. And I like to spell correctly. Alright. Make sure that goes on to the next line. So now if this thing were to succeed, we would find out. But once again, we need to have the little create info struct right here. So we're going to go ahead and create that now. So we just go ahead and do a vk instance create info. There you go, right there. And let's go ahead and call that, we'll just call it create info. Nice and simple. And this just initializes an empty one. So now that we have that, even though we haven't actually fixed any of the data in it yet, let's go ahead and add that into our vk create instance. So we just put in a reference to the create info struct. And now technically that call is correct. I mean, it's not getting any of the information it needs, but it could succeed in theory. So now we need to fill out the create info struct, and there's a lot of pieces to this. So first off, we have create info, and there's the S type right here. That's the structure type that we're using, and Vulkan has a bunch of these pre-built, so it's going to be vk structure type. There we go, structure type. And we're looking for instance create info. And there it is. So that's just helping Vulkan identify what type of structure this is going to be. Next up we have pnext. We don't really need to worry about this too much. This lets you have a linked list of structures. We don't really need to do this, so we're just going to set it to null pointer. Alright, what else have we got next here? Flags. Flags, once again, we're not going to bother with right now, so we're just going to set that to 0 because there are 0 flags being used. P application info. There we go. And this is going to be another struct. We're actually doing this in reverse because it makes a little bit more sense. So to do a vk create instance, you need the create info struct, and to make a create info struct, you need an application info struct. So we're going to leave that blank for now. It's going to give us some errors because we're not filling it out, but we'll come right back to it in just a second. Alright, now we have the enabled layer count. And for now, we're going to go ahead and set it to 0. This is going to change in a second when we start messing with the validation layers, but we'll keep it simple for now. And when you have the enabled layer count, you also have the pp enabled layer names, which just is all of the layers that are being used. Since we're not using any, we're just going to go ahead and set that to null pointer. There we go. And we also have extensions, so it's going to be similar to the layers. We do create info enabled extension count, and this one's going to be a little bit different because we are going to use some extensions. Since we're using GLFW, that actually has to pass some extensions so that Vulkan can interface with it. So first off, GLFW actually has a function to return the extensions associated with it. So we're going to create an unsigned int. Alright, we're going to call that GLFW extension count. There we go. And we'll just start it at 0. And we're going to create a constant char, star star. And that's going to be GLFW extensions. So what that is, that's an array of pointers. And so then, to get the actual extensions themselves, we're going to say GLFW extensions. And we're going to assign that to GLFW get required instance extensions. And it might not be recognizing that. Yes, it is not. And the reason for that is we need to include a reference to GLFW. So the way we do that, because we're including Vulkan, what we actually need to include is GLFW with Vulkan. It's something that's built into GLFW. So what we're going to do here is we hash define, and it's GLFW include Vulkan. Let's see if that worked there. Yes, it did. Perfect. And of course, we probably should include GLFW as well. So GLFW slash GLFW 3.h. Doesn't seem to be happy with that. Oh, there we go. Just took a second. Great. So now that we have that, it should recognize this function call. Yes, it does. Wonderful. We still need to pass in an argument here, and that's going to be the extension count. So go ahead and get a reference to the GLFW extension count. Perfect. All right. So now that we have that, that's going to find all the required extensions, and then it's going to change extension count to match the number that were found. So since we have the createInfo.enabled extension count, we can assign that to whatever value is now in GLFW extension count. And then createInfo, pp enabled extension names, and that can just be GLFW extensions. Makes things nice and simple, not have to do too much work here. Alright, so now that we've got that, everything's set up for our create info, but we're still missing that p application info struct that we were going to pass in. So we're going to make another one right above it, just like we did before. And once again, we're going to declare it before we actually do anything. So vk application info, call it app info, and now we're going to start filling it out piece by piece, just like we did before. So it's very similar in structure. A lot of the Vulkan structs have a lot of the same components. So once again, appinfo.sttype, and this is going to be a vk structure type application info. There you go. Once again, we're going to have pnext is going to be null pointer. We have appinfo.application p application name, and this is just whatever we want to call it. For now, I'm going to call it Planet Vulkan. Maybe we'll change that later, but right now it doesn't make a huge bit of difference. And we also need appinfo application version. This is going to be the version of the current version of the application. And we're just going to set that to vk make version 100. You can see that's major version, minor version, and patch version. Oh, put 2 dots. We don't want that. Alright. Now we need engine name, so appinfo p engine name, and I'm just going to call this no engine. This is some stuff that I've borrowed from Alexander's tutorial again. I may end up changing it later on, but for now, let's just get things working. And appinfo.engine version. Once again, we're going to do vk make version 100. And now we need API version. So this is going to be the minimum version of Vulkan that can run our application. So appinfo.api version, and we're do vk API version 1.0. So that designates the minimum version of Vulkan that can run, which is already the minimum version of Vulkan, so it'll work out nicely. And that should be everything we need. So now that we have app info, let's not forget to add it down here. So app info. Oh, sorry. I believe that needs to be a reference to app info. There we go. Now it's happy. And that should be everything we need. What we have right now should theoretically initialize Vulkan. And since we're already calling init Vulkan from tester game, let's rebuild this and see if we can actually get it to work. Alright, so we got that built. Perfect. And let's go ahead and run tester game. And it should start up, give us a window, and then tell us that Vulkan was initialized successfully if everything worked out. Let's see. How did things work? And when this right here, Vulkan instance created successfully. So we've finally got Vulkan running. Now let's get to the validation layers. Now this is going to get a little bit messy, but it's all going to be worth it because having some sort of callback for when we get an error is going to be particularly helpful. And in this case, I'm going to be following Alexander's tutorial pretty darn closely. So once again, I would recommend checking out his tutorial. I'll provide a link to it in the description. But let's go ahead and dive right into this. So first off, we need to enable the validation layers. So over here in planetvulkan.h, here we go, we are going to create a vector of all of the validation layers that are being included. So do a const vector, and it's going to be a vector of constant character pointers. And these are going to be the validation layers. just like that. Oh, and we haven't included vector yet, so let's go ahead and drop that right in there. There we go, just add vector, so it actually has some idea what I'm talking about. Did we have vector over here? We didn't. Okay, good. Alright, so those are our validation layers, and we're going to go ahead and assign them. We have this nice little input we can put here, which is VK layer LunarG standard validation. And this is something that's built into the Vulkan SDK. It gives us all the validation layers that are the standard set for this SDK, and it's particularly helpful. It's pretty much everything we need. Alright, now we really don't want to run the validation layers when we are at runtime. We only need them when we're debugging. So we're going to go ahead and use some preprocessor directives to make sure that this only happens when we are in debug mode. So we're going to create a constant bool, call it enable validation layers, and we're going to make two versions of it. There's one where it's initialized to false at the start, and another one where it's initialized to true. So we're going to use this later on in our code to check whether or not they've been enabled. Now right now this is terrible programming because you've just declared the same variable twice. So what we're going to do is these are the preprocessor directives. If defined, and so that's checking whether or not we're in debug. So if not debug, then they're false. But we also want them to be activated if we are in debug. So then we make else, and then this go ahead. That would be set to true, and then we end the if. So now, if we are not in debug, the validation layers are false. If we are, they're true. And we're going to actually use that variable later. Right now it's not really doing anything, but it's going to come in handy. Now we also need to check whether or not all of the validation layers we requested are supported. So right here we're requesting the standard validation set from the Vulkan SDK. We got to make sure that those are actually available. So we're going to create another function right here, just bool, not create, check validation layer support. So that'll test whether or not all of the layers are supported. If it succeeds, then obviously they are, and if not, it's a failure. So let's go ahead and just grab that from here. And we're going to add it in right underneath create instance. And once again, we need to give it its scope. There we are. So what we're going to do here is we are going to find all the available layers and then iterate through the validation layers to make sure that all the ones being used are part of the available layers that we found. So to find the available layers, we need to call VK enumerate instance layer properties. Oh, here we go. VK enumerate instance layer properties. Bit of a mouthful. And we're actually going to need to do this twice. This is something that we're going to encounter a lot when we're working with Vulkan, because when it returns that, it can return a number of layers, and we want to create a vector that's holding all the layers returned, but we can't know what size to make it until that gives us a number. So the way we're going to build this, we're actually going to use a uint32. This is what Vulkan prefers, because it is, uint32t, because it is a universal type. It is unsigned and it is 32 bits. And we're just going to call it layer count. Okay. So once again, here's the first call to this. We're going to reference layer count, and then normally the second argument you would pass in the properties reference, but this is what we're going to fill in a second. So right now we're just going to set that to null pointer. Okay, so when this returns, it will just give layer count a number of layers that we found. Now we're going to declare that vector I was telling you about, so std vector, and this is going to be a vector of vk layer properties. I'll just call it available layers, and we're going to pass it layer count. So now it is the size of the number of layers that we're about to find. And I'm just going to copy and paste this. It's probably not the best programming practice, but it works nicely here. And once again, we're passing it the same number, but instead of null pointer, we're going to pass in available layers data. And that's just going to go ahead and give it all of the data that we need. So now that we've gotten all of the available layers, we need to iterate through the validation layers and make sure that all of them are within the available layers. So we're going to go ahead and make a for loop. And for each constant character pointer, layer name in the validation layers. And remember, that's one that's been assigned over here with VK layer, LunarG, standard validation. So it's going to iterate through everything that was returned in that call. And it's going to check whether or not it's in available layers. So we're going to use a bool, layer found equals false. So it's going to assume it's not found, and then it's going to iterate through all of the available layers. We're going to use the auto keyword here. Auto just takes whatever type is returned and automatically assigns that. It's a particularly useful way of declaring a variable. And there's going to be layer properties. And that's just the name that we made up for it. And it's going to be out of available layers. So it's going to iterate through all available layers, each time returning a layer property object. And now we need to compare those layers, so we need to actually check if the available layer that we are testing right now could match up with that layer name from the validation layers. So what we're going to go ahead and do is we're going to do if, or do string compare, and we're going to test if layer name, how that compares to layer properties dot layer name. So we just take the two layer names, we compare them, and string compare returns a 0 if they equal. So we'll say if it equals 0, then we know that we've found that particular layer. So we can say layer found equals true. And we can also break out of this loop because we don't need to keep checking if that particular layer is in any of the available layers because we found it. And then outside of the for loop, we're going to go ahead and say if layer found equals false, or actually, you know what, let's clean this up a little. Let's just do if not layer found. There we go. And then we can just return false. And underneath this, we will return true. So at any point, if it fails to find one of the layers, it will immediately return false. If it exits the for loop for the validation layers, then we know that every single one was found, and we can just go ahead and return true. So when this returns, we will know whether or not all the layers that we requested are available or not. Also, since we're using that string compare, we should probably go back up to the top here and just go ahead and include cstring, just so it knows where to grab that from. So now that we've done that, we have a way of testing if the layers are all available, and we're going to go ahead and throw that into create instance, because if we don't have the layers and we're requesting them, we already have a problem. So right here we're going to check for validation layer availability, and we're just going to say if, let's go ahead and add the braces for that, if enable validation layers, which that's the one that's going to be assigned at the start based on the preprocessor directive. So if it turns out that enable validation layers is true, then it will actually check the rest of this. So if enable validation layers and not check validation layer support, so that's going to go ahead and call check validation layer support, and if that fails, then we really need to immediately get out of here because we messed something up. So we're going to throw std runtime error, and we'll just say validation layers requested but not available. So now it'll double check just to make sure all of those validation layers exist, and if they don't, it will throw an error. So now we have the validation layers enabled, but we actually need to set up a callback so we can receive all the messages returned by the layers. So this is actually going to require an extension, and we were using some extensions before. That was with the GLFW extensions. It's going to get a little bit messier now. So the extension we need is vkext debug report. So first off, we need a function to grab those. So we're going to go back to our header file, and we're going to make another vector. And this is going to be a vector of constant character pointers. And this is going to be get required extensions. So we're going to use this to kind of simplify our extension code in a minute. So let's go back over to our CPP file, drop down here, and once again, we need the scope for it. Actually, I think I might have, yep, I did. I forgot my parentheses. That's bad. Okay, so we have get required extensions right here. And what it's actually going to do is it's going to return different numbers of extensions based on whether or not we had the layers enabled, whether or not we need those debug callbacks. So first off, we're going to go ahead and make a vector inside, just like the one outside, because it's going to return this later. And this is going to be extensions, so that's what's going to be returned by the function. And now we're actually going to need the same code that we were using before, because the extensions that we found in create instance up here, that's all going to be handled by this function. So we're just going to grab this pack of stuff right here, everything that's grabbing the GLFW extensions. That doesn't need to be there anymore. That we can move right down into get required extensions. Let's drop it in there. So we'll come back to that in just a second. Ultimately, this function is going to return extensions. So since we know that, we're going to fill in the rest of this in just a minute, but knowing that it's going to return extensions in a second, up here, when we did all the messy extension code before, we can just say auto extensions equals get required extensions. So it's just going to call that function to get a whole vector of the extensions. And now down here in the enabled extension count and enabled extension names, we don't actually need to put something specific. We can just do extensions.size, which will be the number of them, and extensions.data. And that handles it. It's pretty nice. So let's get back down to the actual get required extensions function. So we're now handling the GLFW extensions, but we aren't handling any of the callback extensions. So what we're going to do is for unsigned int I equals 0. We're just going to do a nice iterative for loop here. So this is going to iterate through all of the extensions that are in the GLFW extensions. And since we have this vector for extensions right here, but the GLFW extensions are separate, we're going to add each one of them to that vector. So we're just going to say extensions dot pushback, which will just add this to the end of the vector, and GLFW extensions I. So it'll iterate through all of them, it'll push each one onto that vector, and this would be sufficient right now. This would all compile nicely, but we have to handle those validation layers as well. So we're going to say if enabled validation layers, so if we're running in debug mode, then we're also going to do extensions.pushback, and this was what I mentioned before. We need the vk-ext debug report extension name. That's what we want right there. And so that will add that on to the extensions we need. And we could always add in other stuff here later to increase the number of extensions that are returned. So that way we don't have to worry about extensions anymore. They're all just kind of handled in this function. Alright, so let's create an actual callback function now for the validation layer to use. So this is going to get super messy, but I'll do my best to explain it. So we're going to go ahead and create a, here we go, a static. It's going to be a vkbool32, and we're going to call it DebugCallback. So we also need to add some things right here. We're going to add vkapi attr, and we're going to add vk API, and this is call. These are just some signatures so that Vulkan actually understands how to call this function. And now we need to add in a lot of other stuff. It's going to get fun. So these are all the things that need to go in here. We need a vk debug report flags ext. Let's call that flags. Next up we have the vk debug report object type ext. That's going to be object type. Yeah, and this is some messy stuff. If you don't understand all of it, don't feel bad. I mean, this is the kind of thing you pretty much have to look up. Next up we have uint 64t object. Oh, unit. Don't misspell things. That is bad in programming. Alright. Size t location int 32t code constant char star layer prefix const char star message and void star user data. That's all the things that need to go inside the debug callback. Like I said, super messy stuff. The flag parameter holds the message being output. The object describes which object the call is coming from. Object type is the type of that object. The other parameters aren't super important. What we really care about is the message right here. That's a pointer to the error message as being output. So all we need to do is inside the body of this, I'm just going to bring these down a bit, and I'm keeping this out of the CPP just because it's a very short function. It's going to be much easier to store it here. We need to go ahead and return vk false, just so that Vulkan understands that this is an error. And for the user's benefit, we're going to do standard C error, and then validation layer, and we're going to output the message. So now we won't just get an error, we'll actually get an error with some description as to what's going wrong, and we'll kind of get some feedback on this, which is really important. If you don't know what's going wrong, it's pretty hard to fix it. Now, we're also going to need a handle to the callback object, and like any other Vulkan object, it's going to need to be created and destroyed just the way we did before. So once again, we're going to need that v_deleter. So let's go ahead and create a handle to the debug report callback. So down here, we'll do it after the instance. This is another, in fact, you know what, we're just going to label this. We're going to put all the handles here. We'll call them Vulkan handles, just to keep things nice and organized. So underneath this one, another v_deleter. This one is going to be a vk debug report callback ext. There we are. And like any other one of these that we made, here we'll name it callback, and we're supposed to pass in, for this one, the instance, which we have, so right above it, and then a destroy function, which we don't have yet. So let's go ahead and create a create function and a destroy function for the callback. So right over here above the debug callback object, we're going to go ahead and make a vk result type, which is going to be the create debug report callback ext. Alright, and this is going to be another one where we have to kind of fill in some arguments later. We're going to come back to that. So, and then we're also going to make a static void destroy debug report. Oh, come on. I can get the capitals right. Callback ext. So now we have a destroy function. We haven't filled that one out yet either, but again, why don't we just take that, grab it, bring it down here so we don't forget, and drop it into the v_deleter. So now, in theory, callback knows how to create and destroy itself. Alright, now, let's go on back up here and fill these out. So for the create debug report callback, we're going to go ahead, it needs a vk instance. It needs a constant vk debug report callback create info ext pointer p create info. Did I spell that right? I did. Lowercase k. There we go. Alright, now it needs a const vk allocation callbacks. Perfect. Pointer. P allocator. And then a vk debug report callback ext. Sorry, it's all caps. Ext pointer p callback. Quite a mess, but that's everything we need for that one. And then the destroy one is going to need some as well. So once again, we're going to need a vk instance. I'm just going to copy it. I'm starting to get lazy here. Okay. We need a vk debug report callback ext again. We're just going to call that callback. And then once again we need the p allocator. And that should handle everything we need for the create and the destroy. Now we are going to need to actually fill those out in the CPP, so let's hop back over there. Alright, and we're just going to add these in down at the bottom. Now let's fill these out. So once again, this is all stuff that I looked up from the tutorial. This is not stuff that I just have off the top of my head, so if it's hard to follow, don't feel bad. A lot of the stuff in Vulkan you kind of just have to look up. It's not super intuitive. So once again, give all these their proper scope. There we go. Oh, once again, you can't declare static right here because it's already been declared static. So let's fill out the create first. So up in the create one, we need auto func equals pfn. This is going to be vk create debug report callback ext. So we're just going to cast that, and then we have vk get instance proc adder, pass in the instance, and a string of vk create debug report callback ext. Alright, good. Now that we have that, we're going to say if func does not equal null pointer, so as long as it succeeded, then we're going to go ahead and return func with instance p create info, which would be passed in, p allocator, which would also be passed in, and p callback. Now if it failed, we want to let everyone know, so we're going to go ahead and return vk error extension not present. Now let's go ahead and fill out the destroy one. This is a little bit simpler. So once again, we're going to do auto func. And the reason we're doing this is we have to look up the proper functions since these are extensions. They're not immediately accessible. So vk destroy debug report callback ext. Once again, casting it. vk get instance proc adder instance, and pass in that string again. There we go. So that should find the proper thing. Don't forget our semicolon. And then we're just going to say if func does not equal null pointer again. And if it doesn't, then we need to get rid of it. So we'll just func instance callback p allocator. All right. Doesn't like callback. Okay, so this is why you don't want to copy and paste, because you'll notice the callback here, it's passing in a pointer, and callback here isn't a pointer. It's because I messed up in the declaration. The callback in the destroy is not a pointer, but because I copied it from the create one, which is a pointer, I kind of screwed that up. So this is why you don't want to copy and paste. You can break some things. Let that be a lesson to you all. Alright, so we have the create, we have the destroy, everything should be working nicely now, and actually I think I changed my mind. I think I just want to move these into the header, keep the CPP a little bit cleaner. There's enough here already. So we'll just copy and paste this real quick. So we're just grabbing the body, pulling it out, going to the header, and just dropping it right after the parameters, and of course before the semicolon. And then we're just cutting it completely out of here. Give us a little more room, because we're going to run out of room pretty quickly. Alright, so now that we have that, we don't actually have any way of creating or destroying the callback yet. We have functions for it, but we haven't actually done it. So what we're going to do is we're going to create one more function after create instance called SetupDebugCallback. And that's actually going to initialize it with all the things that we need. And we should probably declare that, in our header file. So this is a good place to copy and paste, because if we don't do it here and some things don't match up, it's going to get angry with us. Alright, it's going to be void. So we've got that, and let's drop it right down here. Once again, giving it the proper scope, Never forget that. There we are. Alright, and so in the setup callback, first we need to check if we're even using validation layers, because if we're not, we don't need to be here. So, my spelling is terrible. Not usually, just when I'm typing with a microphone in my way. So if not enable validation layers, we can just return. We don't need to be here. This is pointless. Now, if we do have validation layers, it's going to be a lot like the other structures we've made. We need to create info for it. So we're going to say vk debug report. Keep counting those e's. Report callback. There it is. Create info ext. Call it create info. And once again, we're just going to create it and then initialize each thing in there we need. So create info.type is going to be equal to vk structure type debug report callback create info ext. That's the one. It is quite a mouthful, but so it goes. Create info dot flags are going to be equal to vk debug report error bit ext, and then we're going to bitwise OR that with vk debug report warning bit ext, and then create info pfn callback is going to equal debug callback. Alright, now we just handle this the same way we've handled any other creation, like when we created the instance. We're just going to say if, and it's going to be create debug report callback ext using our create function. We're going to pass it all the information it needs, which is going to be the instance, reference to create info, once again the allocator, which is going to be a null pointer, and then the p-callback, which since we're using vdeleter again, it's just going to be callback.replace. Remember, we have to do it that way because we're using that vdeleter. And we're going to check whether or not it equaled vk success. So if it does not equal vk success, we throw that error just like before. std runtime error. And failed to set up debug callback. Else. And once again, we don't have to do this, but I always like to, just because it makes me feel a little better. Cout debug callback setup successful. So now, if it succeeds, we will know, and that's kind of what we want. Alright, so now that should take care of just about everything. Let's see if we can actually get this thing to run now. So once again, let's never forget to build the engine. Alright, everything built nicely, so I think we're okay. Oh, actually, you know what? There's one thing we forgot to do. If you remember, we had a layer section when we were setting up the create instance. Where is it? Where is it? Here we go. And we did nothing with that. And we're using validation layers now, which are layers. So if we don't actually add those in, it's pretty useless. So let's go ahead and do that. So we're going to say if enable validation layers, then we want to change how we're doing this. We're not going to do it like it says there. We're going to copy it, and and we're going to say the layer count is going to be equal to validation layers dot size. So now, however many validation layers we have, that's the count. Makes sense. And of course, the layer names is going to be equal to validation layers dot data. So that takes care of that. All this stuff down here, we're still going to keep that. That's going to be our else case. So if we're not using validation layers, it's going to do this stuff. And we're just going to grab all that and move it right up. Okay, that should do the trick. So now let's rebuild this and see how things go. Alright, so it built nicely. Let's go ahead and test tester game. And let's see what we get. And it crashed. Alright, so to better understand what was going wrong, I used the exception settings right here, because it's just crashing, it's not giving me any information about where it's crashing. So what helps is to go to Tools, and then Customize, go to Commands, you drop this down to Debug, go to Add Command, went to Debug again, there it is. And then I went down to exception settings. Where'd it go? Well, it's not there at this point because I already added it in. But you would go ahead and click exception settings, hit OK, OK again, and that will add it right here. And exception settings allowed me to choose when to throw an exception, and I chose to do it when the C++ exceptions happened, so that way these unhandled exceptions would stop me on a particular line. Another thing I did just to prevent myself from messing anything up is over here in Tester Game, I keep forgetting to rebuild PV Engine, and that's causing me some problems. So in Tester Game, if you go to right-click, Build Dependencies, and Project Dependencies, you can go ahead and check PV Engine. If you do that, now anytime you try and run it, it should rebuild PV Engine as well, just to make everything work out properly. Alright, so I finally figured out what the problem was. It turns out that I just didn't have the newest version of the LunarG SDK. What happened was in the header file, when we initialized validation layers to VK layer LunarG standard validation, it wasn't really understanding what this was anymore because it turns out that the SDK was out of date. So just had to go to the website, download the new one, install it, and then I had to go to the properties for both PV Engine and Tester Game. And just when it, for the VCC directories, you had to change the path to the new version. Once I did that, went ahead and built everything, and there it is. The layers are available, the instance is created successfully, and the debug callback is set up. So everything runs, that's all there is to it. Sometimes things mess up like this, and you kind of just have to stumble around through it until you figure it out. So that's all for this episode. In the next one, I'm going to set up both the physical and the logical devices, and once that's all done, Vulkan should be ready to go. So thanks for watching. If you have any questions or suggestions, feel free to put a comment in the video, and if you'd like to be notified when a new one pops up, just go ahead and hit subscribe.